What if your dataset could talk to you? Imagine asking a question from your dataset and getting an instant answer. First, we upload our dataset, then prompt, create a visualization of the data. Here's our AI agents at work. Developer crafts the code and executor runs it immediately. And there it is, your data brought to life with a dynamic chart. Now I ask, what insights can you spot? Developer and executor dive back into chat. And in seconds, they highlight key patterns and surprising trends. No manual coding required. I'm Mohammed and I'm gonna teach you how to develop this agentic app from scratch. Let's get started. Okay, so we'll be developing this project in two parts. In the first part, we'll develop the backend side, the agentic part. And in the second part, we'll develop the web application with Streamlit. And I've downloaded a dataset beforehand. It's called Netflix Movies and TV Shows. Let me show you the dataset. It's a CSV file containing information about many movies and TV shows of Netflix. You see for each movie or TV show we have title, we have director, we have cast, and rating, duration, and so on and so forth. If you want to download this dataset, you can go to Kaggle and you can just easily search Netflix dataset CSV, and yeah, there we are. This is a dataset, and you can also see some information about different features in the dataset. And if you want to download it, just you need to sign in and you can easily download the CSV file. Okay, so let's develop the backend side as a separate Python file, and then we'll develop the frontend side in another file. So let's call this data.py, and we'll be working with Autogen like previous videos. We'll be working with the most recent version, Autogen 0.5. It's a stable version, and we need two agents in this project. The first agent will be an assistant agent. It is an LLM, and it will provide Python code to answer the question. And we will have a code executor agent. It will execute the code developed by the code developer agent in a Docker container. So without further ado, let's start coding. First thing first, let's import from Autogen. Oh, I need to change my environment. Okay, Autogen. From Autogen agent chat dot agents import AssistantAgent, and we need to pass a model, an LLM, to this assistant agent. So let me import the model as well. From autogenx.openai or .models.openai import OpenAI chat completion client. And by the way, we'll be working with O3 Mini, although O4 Mini was released yesterday, but I couldn't access it through API yet. So let's just work with O3 Mini, just like previous videos. And again, we'll be developing in asynchronous mode. So let's import async.io, and I will define a coroutine, a function in async.io, async def. Let's call it main for now. And here's my model. Model is OpenAI chat completion client. And I need to pass what model do I wish to use, O3 Mini. And I also need to pass my API key. So I forgot to bring my API key here, so now I will copy it. Okay. Just as I've explained in previous videos, please never share your API key with anyone. Share it with GitHub, never push it to your repo. Make sure it's safe. You can either introduce a system variable or you can keep it in a separate file and make sure it is not public. So open API text .read.strip. .read just goes and read the whole file, and .strip make sure there's no extra space in the end. So we have the model right now, and here's the developer. It's an assistant agent. We should pass a name. I will call it developer. And we should also pass a client, model client. It will be model. And I need to specify the system message. And as you see, sometimes GitHub Copilot suggests the wrong syntax, so please never trust it blindly. It is so common, especially in these libraries such as Autogen. They're pretty new and it isn't trained well on these libraries. Okay, so you are a developer agent, code developer agent. You will be given a CSV file and a question about it. You can develop Python code to answer the question. I should specify that it needs to come up with code in code blocks because my code executor only accepts code blocks. So you should always write the code in a code block with language which is Python specified. Okay, and let me also specify that the agent should first come up with a plan and then develop the necessary code. Let me specify this. You can develop Python code to answer the question. You should always begin with your plan to answer the question. Then you should write the code to answer the question, and you should always write the code in a code block with language specified. If you need several code blocks, make sure to write down one at a time. And I should also say that you'll be working with the Code Executor agent. You will be working with a Code Executor agent. Once you have a code block, you must wait for the Code Executor agent to execute the code. If the code is executed successfully, you can continue. And once you have the code execution results, you should provide the final answer. Okay, it's good for now. And yeah, so this is the code developer agent. I should also define the code executor agent, and let me define it. Code executor agent, I should import it first. Autogen has a Docker class, has a class to work with Docker, so I should also import that as well from autogenx code executors .docker import Docker command line code executor. Okay. So I will define a Docker object. It will be a Docker command line code executor. I can specify the image. Let's go with Python 3 Slim, the default image for now, but we can also specify other images as well. I can also pass container name or let it decide, or I can pass a working directory. So the name is, I don't need names for this, sorry. Yeah. Working directory will be a temp folder, and we're good for now. And here's the executor agent. It will be a code executor agent object. The name is code executor, fair enough, and it needs the code executor object. I will pass Docker. Okay, so now I have two agents, the developer and the executor, and I should make a team out of these two agents. As you can remember from previous videos, we have three types of teams in Autogen. Let me show you. So Autogen documentation. Today we'll be working with RoundRobinGroupChat, Autogen agent chat, and here's the teams. So we'll be working with RoundRobinGroupChat. In RoundRobin, as you can see the description, it's a team that runs a group chat with participants taking turns in a round-robin fashion. It means that the team behaves deterministically, so we know beforehand which agent will respond when. So for example, if I pass the code developer and the code executor, it will first prompt the code developer and then the code executor and then the code developer and then the code executor. So they'll just take turns and respond. So let me import RoundRobinGroupChat from Autogen agent chat.teams. Import RoundRobinGroupChat. Okay, let me define the team. I will call it team. It's a RoundRobinGroupChat. I need to pass the participants. It's developer and then the executor. And I can also specify a termination condition. I forgot to mention it in the system message for the code developer. So here's what I want. Whenever the answer is clear and the code developer has the answer, it should say terminate with capital letters in the end so that I will terminate the chat. So let me import. We have a class for this purpose. Autogen agent chat.conditions, import text mention termination. So I can specify whenever a specific text is mentioned, it will terminate the chat. Okay. Let me specify the termination condition. I can pass a text mention termination object. And what is the text? It's terminate. Okay. And I can also specify the max turns. How many turns in the worst case do I wish the chat to go on? And by each turn, we mean one time each agent should talk. Okay, let's say 20 turns for now. And okay, I should also specify the termination in code developer's system message. So once you have the code executor, the code execution results, you should provide the final answer. And after that, you should exactly say terminate. Okay. terminate the conversation. Okay. Now I can test if everything's okay. So as you can remember from previous videos, I can use the run method or the run stream method. I would suggest using the run stream method, because if you use this method, you will have the response of each agent once it is ready. You shouldn't necessarily wait until the end of the chat to have all the messages. So I can have an async for loop. I can say async for message in team.runStream, and I can specify the question now. So let's call it task. For example, what are the columns of the dataset? And let's say my dataset is, I should also introduce the dataset. My dataset is data.csv. What are the columns of the dataset? Okay. I will pass this question as task to the team. And now this message could be either a text message, which is the class that represents the messages between agents in Autogen, or it can be a run result, I guess. Maybe I'm wrong, but I guess it's a run result. So we'll see what it is. And I need to handle these two cases separately. So I should say, okay, if message is a text message, so if is instance message and text message, and I should also import text message from Autogen agent chat dot messages, import text message. And to see what will be the returning type of run stream, let me read the documentation. Yeah, it's a task result, sorry. So it could be either a text message or a task result. So if it's a text message, just print message dot, we have a role for, we have a source for the message, for the sender of the message, a column, and message.content. And else if message is an instance of task result, and I should also import task result as well from Autogen agent chat dot teams, import, let's see if we have task result here. No, I cannot remember where to import it, so let's check the documentation. And by the way, this is a very important skill, to be able to extract the answers to your questions from documentation or GitHub. So practice this skill, is really important. I have RoundRobinGroupChat, and I want to see the documentation for the run result method. Since a RoundRobinGroupChat has a base class, the base group chat, I can go to base group chat's documentation, and here's the run, and here's the run stream. Yeah, and here's the task result. And you can see task result is in Autogen agent chat.base. So Autogen agent chat.base, import task result. Okay, so whenever it's a task result object, I just want to see what was the reason for the chat to stop. Maybe the max turn has reached, or maybe the terminate expression has been mentioned. So print stop reason, message.stopReason. Now I can run my code and see if everything works. So if name equals main, async.io.run, the main coroutine. So this line just creates an event loop, and if you don't know what is an event loop, don't worry about it. In async.io, we need an event loop so that it can run different coroutines. And by coroutine, I mean just think of a coroutine as a normal function, but instead of waiting for that function to execute and doing nothing else, we can execute several coroutines at the same time. It's especially beneficial when our application is I/O bound, when we're waiting for some outsider to provide the result for us, and that is the case for the agents. That's usually the case. So let me run the code. Python data.py. Oh, I forgot to start the Docker object. We should start it, and in the end we should stop it. So before the team starts working, I need to say await. Await keyword is used to call a coroutine. So await docker.start, and once the chat is done, I can say await docker.stop. Okay, let's run the code again. You see, pandas was not installed, and it installed pandas, I guess. Let's see what happened. This is our message, the user message, and then this is the developer's response. The plan is to load the CSV file, extract the column, and print the list of columns. And this was the code provided by the code developer agent. And the code executor tried to run the code, but it failed because pandas was not installed. So it's a good idea to also mention pandas in the system message, because sometimes it might try to use other tools, but I wanted to use pandas most of the time if it's suitable. So since pandas is not available, I used the built-in CSV module. So it now tries to work with the CSV module, and it couldn't find data.csv. And that's because my data is here, but the working directory of Docker is here. And you can see the codes that it developed goes into these temporary files. Okay. So for now, let me just copy data.csv into the temp directory. Copy data.csv into temp. Okay. And now I can also specify that you should use pandas most of the time. You are a code developer agent. You'll be given a CSV file and a question about it. You can develop Python code to answer the question. You should always begin with your plan, and you should always write the code in a code block. If you need several code blocks, do this and this. You will be working with a code executor. You must wait. So you can continue. Okay. Use pandas to answer the question if possible. If a library is not installed, use pip to install it. And use pip in a shell code block with shell specified to install it. I'm saying this because in in a previous video, we saw that when we didn't specify this sentence and this instruction, it tried to install the library inside the Python code, which is really which makes the code really ugly. So that's why I'm explicitly asking it to use pip install in shell code block instead of trying to come up with a creative or with an ostensibly creative way. Okay, so let me run the code again. Yeah, you see pandas was not installed, and now it tries to pip install pandas. And don't forget our question, it was this one. What are the columns of the dataset? Okay, this is the code, and these are the columns. And this is the developer's final answer. And after saying the final answer, we have the terminate expression, and the stop reason is that text terminate was mentioned. Okay, so we're good now, but let's postpone the improvement after we have a minimal UI. So now we have a working team. We can pass a question about our data, and they will provide the answer for us, a code developer and a code executor. So I can say we're in a safe spot now for our backend, for our agentic part. Let's develop the web application with Streamlit. So let's create app.py and let's import Streamlit as st. So here's my plan. I want to file upload dialog to be able to upload my dataset, and then the user opens the dataset, and then I would like to have a text input at the bottom, just like ChatGPT or other chatbots, so that the user can write the prompt, and once we have the prompt, then the agents start working. Okay, let's start. I can specify the title, st.title, talk with your dataset, and Streamlit has a bunch of elements to facilitate chat visualization. So one of these elements is chat message. We've seen this one in previous videos. The other one is a chat input. So it will be the text input at the bottom so that we can write our prompt in it. I would say prompt equals st.chat input. Okay, I can specify the placeholder. Let's say ask a question about your dataset, something like this, and that's enough. And I should also specify a container object to visualize the chat in. So container is an st.container, or let's call it chat container. And just to illustrate how this works, let me say if prompt, if we have any prompt with chat container st.write. Fair enough, you asked prompt. Okay, let me run this web application. Of course, it's not connected to the backend yet, but let's see how this logic works. Python, oh, and I cannot say Python app.py, so I should say Streamlit run app.py. Okay, talk with your dataset, ask a question about your dataset. I would say anything, and I have it here. Okay, so let's connect the data.py to app.py now. Let's connect the backend to the frontend. As you've seen in previous videos, I would like to do it in a more modular way. So I will split this main coroutine into two coroutines, a coroutine for team configuration and a coroutine to orchestrate the team. So let's say async def team config, and it doesn't need anything. I will copy from the beginning to the definition of the team. So this will be the team definition. And in the end, I will return the Docker object and the team object. So return team and Docker. And instead of main, I may call it orchestrate. It gets the team object and the Docker object and the task. And here's how it works. I will start Docker. Instead of hard coding task here, I will put it outside this coroutine. So await docker.start, and then for each message in team.runStream, just print the message. Okay. And now I will define a main coroutine. Here's my task. I would say team and Docker equals await team config. After you have team and Docker, I need to orchestrate. This will work now. Let's see if it works or not. No, I don't want to execute. I don't want to run the Streamlit app now. Let's just run data.py because I want it to be standalone. I want it to be able to run successfully independent of the front end. And you can see now the agents are working. Pandas was not installed initially, so it is trying to install pandas, and it will eventually work and provide the correct answer. Okay, so here's the final answer, and here's the terminate expression. Let me clear the terminal. So here we are, but again, I don't like this version. I want the orchestrate to be an async generator so that I can access each message once I have it. So instead of just printing the message, I will call it message, and I will yield message. And for stop reason, do I need that? Yeah, let's say I also want to visualize the stop reason in my web application. So the same way, I will define the message and I will yield the message. And if I want to orchestrate the agents with this new configuration, with this new architecture, I would say I need to iterate over this generator. So async for message in orchestrate team, Docker, and task. And do I need to do anything? No, because I have print inside this orchestrate coroutine, or it's not really a coroutine inside this orchestrate async generator. So I can just pass and the code should work again. Let's see. You see pandas was not installed. It is trying to install pandas again. you see, here's the final answer, and here's the terminate. So now I can use these two coroutines, I mean the team config coroutine and the orchestrate async generator inside my web application. Let's import them. From data, import team config and orchestrate. Okay, so once I have a prompt, I would like to create the team and Docker object and then orchestrate the agents. I will define a coroutine here, async def, let's say query or whatever name, and I need to import async IO as well. Import async IO, and inside the query I will create a Docker and team objects, await team config, and then I will like to iterate, I should iterate over the orchestrate generator. So async for message in orchestrate with team, Docker, and prompt. And then, okay, now I need to work with st.chat message. It's an element to visualize each chat message. So first of all, I should see where this message is coming from. Is it from the code developer or from the code executor? And once I know that, I can change the avatar and the name of that agent, in my visualization. So let's say if message dot starts with developer, this means that this message is coming from the developer. Then I would say with st.chat message, and what is the name? I would say, okay, the name is developer, and I can also specify an avatar for that. But let's say the name is AI because it's a predefined string, predefined value for Streamlit chat message. It will have a beautiful icon for an AI agent. So I would say just it's from an AI, and I will render the message with Markdown, and I can say elif message that starts with Code Executor, in that case chat message, but let's say this is an executor, the name is executor, and I can specify the avatar, and for avatar it was a good suggestion, yeah, let's go with this one. And I will render the message as a markdown. Okay. So now that I have this chat visualization, I can create an event loop with async.io.run and run this query coroutine. Okay, and now I can forget about this one. So let's say Streamlit run app.py, talk with your dataset, and here's my question. My data is data.csv, list the columns. Okay, you can see here's the developer, here's the plan, this is the code, and now it's trying to pip install pandas since it's not installed. And pandas is installed now. Here's the code again, here's the result, and here's the final answer. Okay, So it's really working now, but one thing that I really don't like in the current version is that I always need to specify what is my file and where is it located here. I don't want to do that. So let's add a file input object. So a file uploader, so that we can upload our dataset each time instead of talking about it. That would be way easier. Okay, so I would say file equals sc dot. We have this file uploader, and the label would be upload your CSV file. I can also specify what type, what extension should it accept, CSV files. And just let me show you how it looks. Okay, now we have these elements here. We can drag and drop our file here, or we can browse our file, and we'll upload our CSV dataset with this element. And I'm doing this so that we wouldn't need to talk about our data. I mean, say, okay, my data is whatever the CSV. So I don't want to do that in every prompt. So I need to write some code to handle this file uploading process. So here's the file. It will be none if there's no file, but if we have a file uploaded, now I should save it. Here's what I would like to do. I like to save the file in this temp directory, and then I will provide this information in the system message of the code developer agent that the dataset is in temp data.csv. So this way, any dataset with any name will be saved as data.csv, so that the agent always knows where to look for it. So let's say with open. Okay, it should be in temp and data.csv. Let's make it OS agnostic. So import OS, and it will be in os.path.join temp and data.csv. Yeah, I want to write bytes and f.write file.getBuffer. This way, any file I upload, any CSV file, will be saved as temp as data.csv in the temp folder. And then, yeah, then display that file uploaded successfully. Okay, let's see. Let me remove this data.csv from here. And let me run the code. Streamlit run app.py, and okay, here's the dataset. File uploaded successfully, you can see. And if I go to temp, you can see here's the data.csv. Okay. And I should also change the system message of the developer agent. You are a code developer agent. You will be given a CSV file in named data.csv. Okay. Data.csv in your working directory. Okay, let's see if everything works. Let me run the app. And here's my dataset. And here's my question, just the same. List the column names. Here's the developer's plan, and you can see it knows that the data is data.csv. and it's waiting for the code executor's response. Sometimes it can take a while. Oh no. The problem is that we have terminate here. In its plan, it has also talked about terminate, so that's why the chat has been stopped. I need to provide a mechanism so that I can get aware somehow when the chat is terminated, and I can also prevent this happening. So, okay, first of all, I need to also display the stopping reason of the chat inside my web application. Although I've done it in the orchestrate function, I'm also yielding the stop reason message, as you can see here. But in my chat visualization, I have just two conditions for the developer and code executor agents. So let's also say else if message starts with the stop reason. In that case, do I need to? Yeah, let's go on. See the chat message. It can be from user and st.markdown message. I'd also like to have a spinner object here so that whenever the agents are trying to come up with the answer, I want to somehow get notified. So let's say with st.spinner generating response. Yeah. And there you go. So one current problem of our implementation is that, let me show you. Let's run it again. Let's import the dataset. And now let's ask a new question. How many rows does it have? You see, here's the spinner object. At least we know that something's happening. The agents are working. Pandas is installed. You see, we're still working. Okay, so it figured out that we have 8807 number of rows, and here's the stop reason. Text terminate mentioned. Fair enough. But we have a problem right now. Whatever change that happens in this web page, I will lose all of my messages. So for example, let me just get rid of this data.csv. Now all of my messages are gone. So this is because of the logic of Streamlit. This is how Streamlit works. For every change, every event in the web application, it runs this code from top to bottom. It runs this whole code. So in this, when I have an event like, removing a file from this element, or even clicking on any button, if we had any button here, in that case, it runs this code again, and we don't have any new prompt. So this will be none, and we don't go inside this if statement. And that's why we lose all our messages. So I need to somehow retain my memory. I need to somehow remember what messages I had. And this is where Streamlit session states can help me. So I can say, okay, for the first time we're running this code. In that case, we haven't specified messages. We haven't any list to keep track of messages. So in the first time, I want to create a list inside a Streamlit session states. And from the next time on, I don't need to create a new list. I just need to use that list. So I would say if messages not in sc.session state, then create an empty list and call it messages. Okay, so once I have a new chat, once I have a new message, I will append it to my list. So let's say instead of doing it this way, I would say sc.session state.messages.append the message. And I will do it irrespective of who the message is coming from. So I can do this stuff somewhere else. I will create a new function. Let's name it show message. So let's say maybe here's a better place. Def show message, and I have a message, and here I will visualize the message, and I need to also pass the chat container. So show message gets a container and a message, and first of all, inside that container it will say with container display this message. Okay, so I have this coroutine now. Here I would define team and Docker, and now inside the spinner object I iterate over my orchestrate async generator. Once I have a message, I will append it to the message, and then I will show that message. Okay, and before coming into this if statement, I want to show all my previous messages. So let's say I want to continue the chat. Once I have the answer, I want to have another question. I don't want to lose my previous chat. So before this one, I would say for message in sc.session state.messages, show that message. So if I run this code again, you would see that even if some event happens in the web application, I will not lose my previous messages. So let's ask the same question. How many rows do we have? And this is a pain. Every time pandas is not installed and it tries to install pandas. So maybe I can pass an image that already has pandas installed. So this saves me some time and also some cost. So we'll do that next. And yeah, the chat is done. You can see. Here's the developer's plan. And in the end, it says, okay, we have 8,807 rows. And now and you saw I removed the CSV and nothing happened. I can, import it again. I still have the messages, you see. And let me do this one. Let me find another Docker image that has pandas installed. Docker image for pandas. Let's search it. Okay, we have this Docker image. You can find it in Docker Hub, and you can just do it this way, I guess. Let's make sure. What is the latest version? Okay. I don't want Jupyter version. Okay, I want this one. So now I can pass it as an argument to Docker. The image should be this one. And let's see if everything's all right. This is my data, and how many rows? Okay, you can see pandas is already installed. It didn't bother to install it again. So now we can have our answer way faster. But we have one more problem. I don't know if you could guess the problem. If you could guess the problem now, congratulations. You have a very good understanding of how the logic of our application works. But if not, don't be disappointed. It's fine. You don't even know what I'm talking about. So what if I want to ask another question? Let's say list the columns, and let's see what happens. List the columns. I have generating response. And now I have the response. But here's the problem. Let me say render them as a markdown list. Let's see what we have. Okay, this is clearly the wrong answer. You can see. Or let me say, what was my first question? Okay. Since the conversation only contains the current question, it appears that this is the only question. Okay, you can see it now. It doesn't have memory. Although we're visualizing all the chats, you can see here's the beginning, and then we have tons of items, but the agents do not have memory. They cannot remember what we asked them the first time and other times. So what can we do about this, and what is causing this problem? Let's take a look at the code. The problem is that whenever I have a prompt, I would create an event loop, and inside that coroutine that is being executed by the event loop, I will create a new team and a new Docker object, and then I will orchestrate the agent. So as soon as I have this line executed, my team of agents has no memory from previous chats. So I need to somehow mitigate this problem. There are two ways that I know of to how to solve this problem. One way is that we can define team and Docker outside this if statement, so that we define team and Docker only once. But then we have another problem. Team and Docker are connected to just one event loop, and after the first question, this creates another event loop, and then from that point on, they don't have access to the new event loop, and this is another problem we should overcome. Of course, we can overcome this problem as well. We can create one event loop at the beginning and keep track of that event loop, and then here we should just say, okay, inside that event loop, run until complete this query coroutine. So this is one way to overcome this problem, but let's do it in a more agentic way. The round robin group chat or the teams in Autogen have some state. We can save them and we can load them. So if we can save the state of a team once the chat is done, and then we can load it the next time we create a new team, so this problem will be solved. So let's say I wanna save the team's state. So at this instant, the chat is over, and I can save the team's state. So let's say st.session state team state will be await team.save state. Yeah. And before starting to orchestrate the agents, right at this point, I can check and say, okay, if I have team state in my session state, it means I had some previous chats, then load that state. Yeah, await team.load state that team state. This way my agents have access to their previous chats. So you can see once I have the new team, it will load the state of the previous team or previous chats, and then it knows what I'm talking when I ask about an earlier conversation. Okay. So let me run this and let's hope we don't have any bug. Let's browse the file. And how many columns do we have? For example, okay, I have my answer. And now I can say, let's ask another question. Describe the second column, whatever it is. Okay, it is labeled type and it is one of movie or TV show. Fair enough. So now I can ask, what was my first question? And it should note how to answer that. Oh, and it wrote a code to answer it. It's funny. Your first question was, how many columns do we have? You see, now the agents have access to some sort of memory. And the only thing I would like to do is that I would like to also be able to generate plots of the dataset and visualize them here. That's an interesting option. So I just need to specify this in the system message, And just the way we did in the previous video, I mean the video for a team of agents developing code, I can visualize it in Streamlit the same way. So let's go to data.py and let me add some instructions here. If the user asks you to provide a plot, you should use matplotlib to plot it, and you should save it as a PNG file, and you should exactly say generated file name like generated plot.png, for example. Let's go to the next line. In a new line. And you should save it as a PNG file, and you should exactly say generated in a new line after the code executor has executed the code successfully. Has executed the code and generated the plot successfully. Or let's say after you are sure that, because sometimes it, as we saw it earlier, sometimes it just prints generated file name before passing it to the code executor, and this is not what I want. Okay, so I have this in my instructions, and now I can look for this pattern in my messages, and if I have that pattern, I can visualize it with sc.image. In the last video, I mean the video for the team of agents developing code, I used a simple string method to extract the file name, the name of the plot, but here I would like to use a more professional way using regex or re in Python. So let's import regex, and if you don't know about regex, don't worry about it, it's just a minor thing. It helps us to look for specific patterns in a string, and it facilitates the way we search, and it's a strong way of looking for specific patterns in a string. I strongly encourage you to go on and read about it. So let me introduce a new function. Get file name. Yeah, fair suggestion. And I would say match equals re.search. It's right, the pattern is generated, and then a colon, and I need parentheses to find out the exact file name. And what can be inside these parentheses? I can say anything other than spaces, and it can be a bunch of them. And in the end, it should be a .png. Okay, I guess this works. And if match, if it found anything, return match.group of 1. Else, return none. Okay, So, and match.group1 just extracts whatever is inside the parentheses. So it will be basically the file name. So once I want to show a message, I should check, and if I have the file name inside that message, a PNG file name in that pattern, I would like to visualize it. So inside the show message function here, I would say file name equals get file name of this message, and if file name, if I have something, or let's do it in a more Pythonic way, if file name, which is this one, then st.image, and it should be inside the temp. Of course, the agent doesn't know about the temp folder, so I should specify it here, temp and file name. And I can also use a caption for it. The caption will be the file name. Okay, let's see if it works. In the first question, I would ask, show me the columns, the column names, let's say. I don't want it to print out the whole data set. Okay, these are the column names. Now I would like to have a histogram of duration or release year. Yeah. So generate a plot of histogram of the release year. Let's see if it works. Okay. It didn't have matplotlib installed, so it installed it. Plot saved as release, and yeah, we have the histogram now. And since it's a Streamlit image component, we can also, make it full screen and then go back. So now we have an application in which we can upload our CSV dataset, and we can chat with our dataset. We can ask questions about it. Let me run another example. Let's say, give me some insights about the dataset. You see, it is trying to run some code to get an idea about the dataset. And yeah, the dataset contains this many entries and 12 columns. It represents two main types, this amount of movies and this amount of TV shows. Among directors, these guys are the top 5 most frequent. These are interesting facts about the dataset. And you can also ask it to, for example, how many vsync values are there? So how many missing values are there? And it can answer you quite fast. You see, the code executor executed the code, and for each column you can see how many missing values you have. And you can ask more interesting questions. If you have a funny example, a funny use case for this application, a funny prompt, please write down in the comments so that we can see it and we can get aware of that. So that's it for today. We've developed an agentic application from scratch in which 2 agents can work together as a team, and they can answer the questions about our data set. We've also developed a minimal Streamlit application, Streamlit web application for that. And you can see the agents have memory. They can plot for you. They can answer your questions. Personally, I find it so exciting, and I really enjoy developing these kinds of projects. If you have any other interesting project in your mind, please comment it, and I'll make sure to record a tutorial for that as well in the future. That's it from me. Thank you so much, and take care.